Let's start with the important property of the wave, the superposition and the interference. We have that if two or more traveling waves are moving through a medium, the resultant value of the wave function at any point is the algebraic sum of the value of the wave functions of the individual waves. It means that if you have a wave traveling in a medium, okay, if you have a wave traveling in a medium like this, and also you have another wave traveling in the medium like this too. The medium will oscillate according to the disturbance of the wave. And if at an instant of time, if these two waves pass through the medium, and if you take the snapshot of these two waves and you see the displacement from the first wave like this and the displacement from the second wave like this, we will have that the displacement, the total displacement of the medium is the sum of the displacement of each wave. Okay, it's the sum of each displacement of each wave. So we will have that in this situation we have what we call the construction interference, that is two waves oscillate in the same manner, in the same direction. It means that if the first wave the displacement is up like this, for the second wave the displacement is also up. For the first wave, if the displacement go down like this, and the displacement for the second wave is go down like this too, the resulting wave will be the wave with the larger amplitude. This is the result of the combination or the superposition of the first and the second wave. But the situation can also be like this. You have the first wave like this, and you have the second wave like this. Okay. At this instant, the first wave displacement go up, but for the second wave the displacement go down at this position. And if you look at this position, the displacement of the second wave go up, but the displacement for the first wave go down. So in this situation, what we will have is that the resultant wave can be as small like this. This is because the results of the destructive interference between the first and the second wave, because the displacement point in the opposite direction. So the resulting displacement reduced or even can be zero. Okay, the resulting displacement reduced and sometimes can be even equal to zero. This figure shows what we have just discussed, but in this situation there is two pulse waves that move in the opposite direction. The wave number 1 move to the right, the wave number 2 move to the left, and there is a superposition at this region that the total displacement is equal to the sum of the displacement of each wave. The important point is that once the wave move away from each other, in this case it is these two poles, the pole preserve its original shape. So it's just passed through each other, but the medium at the instant when these two waves pass through each other, the displacement of the medium is the sum of the displacement of each wave. But there is no effect on the shape of the wave when they pass each other. So this is the property of the wave. You can see that we have the constructive interference here because the displacement of these two poles point in the same direction. But in this series, you can see it is a destructive interference because the displacement of the pole number 1 and number 2 point in the opposite direction.